All right, so it said plot the complex number and then find its absolute value. So if I'm plotting negative 3, 5, then this is on the imaginary axis, which is the vertical one. The real is the horizontal one. This would be negative 3 back 3 and up 5. 1, 2, 3, 4, 5. And remember, this is a point and not a vertex. I mean, not a vector. Okay, so there's no line there. It's just a point. And then the absolute value of this is just like the magnitude of a vector. So I would do the square root of negative 3 squared, which is 9, plus 5 squared, which is 25, and I get the square root of 34. That would be your magnitude. Questions on that one? All right, 2, negative 5i would be what in point form? 0, negative 5. So on my vertical axis down 1, 2, 3, 4, 5, that would be my point. And my magnitude, 0 squared, which is 0, plus 5 squared, which is 25, square root of 25, which is 5. Or not magnitude, sorry, absolute value. All right, then 3 and 4 said write the complex number in trig form. So the ending result formula would be that z equals r times cosine of theta plus I sine of theta. And the multiple parts of this is 1, I would try to graph it, see what it looks like so that you can help with the angle. 2, you're going to find your r, which is your absolute value. And 3 is the theta part of this. So the absolute value of r, which we already did this one. This is the same thing as number 2. So I already know that r is 5. If I hadn't already done it, then obviously I would work out r. And then we know where it's located because it's already graphed. We know that's actually on what angle? 3 pi over 2. So it should be consistent with what we find from tangent, but obviously we need to know because there's going to be 2 options which one to pick. So remember the tangent of theta would be b over a. That's your opposite over adjacent if I drew that out. In this case, the b is my negative 5. The a is 0. And so this is undefined. So I'm trying to find where on my unit circle tangent is undefined. And your calculator is not going to help with this one. Okay, this is where you've got to know your stuff. So today when you fill out your circle, feel free to add on your tangents. Like pi over 2 and negative pi over, and I'm sorry, 3 pi over 2, it's undefined. 0 and pi, it's 0. And then all the over 6s are your root 3 over 3s. Over 4s, 1, over 3s, root 3s. So again, you could feel free to add that on if you want to. You could write it off to the side on one quadrant so that you don't have to repeat it every time. Use that circle however you need to use it. So because tangent is undefined at pi over 2 and 3 pi over 2, this is when we fall back on our graph. And that point there is at 3 pi over 2. So theta is 3 pi over 2. And then I plug in the r and the theta. So z equals r, which we said was 5, times the cosine of 3 pi over 2, plus I times the sine of 3 pi over 2. And then those are easy to check. So you can actually check that with your unit circle. If you're going to check this with a calculator, you need to make sure you switch your mode. This is the only time you would switch your mode to radians. So be really careful, okay? The rest of the test is in degrees. But if you're going to check this with your calculator, it should be in radians. And it's not going to give you the I part, but it will at least give you the individual parts. Carlos?
How are you able to determine whether it's like 3 pi over 2 or just pi?
That's where the graph comes into play.
You just use the graph.
Yep. The graph's going to show you exactly what quadrant it's in. And then you're going to have 2 options for every single answer. You're going to have to figure out from the graph which one to pick. All right, so then 4 is 1 plus I, which in coordinate form would be 1, 1. So if I were to rough sketch it, I'd go over 1 and up 1. I know I'm in my first quadrant. My radius would be the square root of 1 squared plus 1 squared, or square root of 2. And the tangent of theta is 1 over 1, which is 1. So again, hopefully you know that the tangent is 1 at what 2 angles? So if I didn't have my plotted point, what 2 angles is tangent 1? 45, which is pi over 4.
And then 135.
Good, which is 5 pi over 4. So those are the 2 angles I'd have that were my options, but because we've already graphed it, I know which one to pick. Which one?
Pi over 4.
Good. And then I just plug it in. So z equals r, which is root 2, times the cosine at pi over 4, plus I times the sine at pi over 4. And then again, these are the last one. This is the last kind of question, so you'll know if you have the time to check it, but those are easy to check. Yep.
Do you think for like when we did the unit circle, do you think we should know the degrees or just really the radians?
It's totally up to you. So you can get some in degrees, you can get some in radians. So I'm not going to tell you one way or the other, right? Like on the 6365, there's a question that was like in degrees. So it's totally up to you. I would say fill out as much as you can today. It doesn't hurt to fill it out. It's not like it's going to be too much information. Fill out what you can. If you don't get to it, you don't get to it. Just like the points. Like maybe you don't have to fill out every single point. Every over 4 is going to be the same. Every over 3 is going to be the same. Every over 6 is going to be the same. Just pay attention to your signs. That's it. Everybody else okay on the warm-up? Yep. Okay, so then the extra review. I got it. Started with number 1 being find the component form and the magnitude. So the component form should have been -12, -6. And the magnitude was the square root of 80, which you will give me as 6 root 5. So these are ones you'll keep exact. I don't want decimal answers on these. On your test, I put, if it's supposed to be a decimal answer, it will say round to the nearest blank, okay? And those will only happen on ones you have to use a calculator for. So if you can find their answer without using a calculator, then do that. Like law of sines, law of cosines, obviously you need your calculators for. Word problem, you need your calculators for. On these, the angle between, you need your calculators for. But other than that, pretty much everything is in exact answer format.
How did you get -12 instead of +12?
You have to do the second one minus the first one. So remember, it's terminal minus initial. And it wasn't labeled initial and terminal, but if you look at the way it's written, the arrow goes over the terminal one. So it's always the last one minus the first one, which won't affect your magnitude, but it will your component form. All right, then 2 and 3. So, I mean, obviously you're like sketching something like that, right? So that said to just graph it. In number 2, it was 5, -12. I just went by 2s to get it onto the graph. Make sure you don't forget your arrows. A lot of people forget the arrows on the vectors. You're going to lose points if you forget the arrow. Otherwise, it's just a segment, which is not what this is. And 3 would have been 2 root 2 for the magnitude. And again, the sketch is there. 4 and 5, component form of the vector with the given magnitude and directional angle. Okay, or the angle formed with the x-axis. Those are the same thing. So this one's in degrees. 4 is on your unit circle, 5's not. So 4, you would use your unit circle, not your calculator, and 5, you'd have to use your calculator. So the formula for this is the magnitude times the cosine of the angle, comma, the magnitude times the sine of the angle. For 4, it's 3 and then 3 root 3, and for 5, it's 6.62 and 23.07. Again, if it's decimal, I wrote what to round to on your test. Like I know it's not on this, but. Questions so far? All right, 6 and 7. 6 is the component form so you're doing the scalar and subtraction. I distributed the 4 in, and then I distributed a +6 and then subtracted. You could have distributed a 4 and distributed a -6. You just got to add it. Either way, you should get that 36 -16. And then if that was given to you in IJ format, you want to put it back in IJ format. This one's given to you in regular component form, so that's why it stays that way. 7 is the unit vector. I got a couple of question marks on the unit vector. Remember, the unit vector is something that's in the same direction, but it's only 1 unit long, so the magnitude should be 1. So you're doing the component form of the vector that you have over the magnitude of it. So the component form was -10, 10, and the magnitude was the square root of 200, or 10 root 2. And then you would want to split it. So it becomes -10 over 10 root, or sorry, yeah. -10 over 10 root 2 and +10 over 10 root 2, and then simplify it and rationalize it. And you get -root 2 over 2 and +root 2 over 2. And again, if that was given to you in IJ, you make sure you give it back to me in IJ. And the unit vector is one that's easy to check too because the magnitude should be 1. So if I take this and I do the square root of a squared plus b squared, I should get 1. So unit means it's only 1 unit long. Amina.
On number 6, did you divide it by 4?
Take it. So I distributed the 4 into the F?
Oh, I was just telling you to find the, okay, never mind.
Yeah. And if it asks if that's a scalar or a vector, what would that be? What would 6 be? 6 would be a vector, right? It's got 2 parts. Yeah. So if it's got 2 parts in component form, then it's a vector. If it was a single number like you ended up with a dot product, that would be a scalar. Okay, 8 and 9 were your dot products. So 8 is 63 and 9 is -4. And then 10 and 11 were the relationship between the 2 vectors. Are they parallel, are they orthogonal, or neither? So remember, parallel, we want to compare their slopes. If you look at a vector in component form, that's change in x, comma, change in y. You can put either one over either as long as you're consistent. But if I wanted to find the slope of uv, I would have put the change in y over the change in x, which is -9 over 4. The slope of v is 4 over -9. They are reciprocals, but they're not opposites. So they either have to be exactly the same or they have to be opposite reciprocals, which means that this is neither. So there's one way to check for parallel. There's 2 ways to check for orthogonal. So orthogonal is perpendicular, which means slopes could be opposite reciprocal. Or what's true about the dot product? If it's orthogonal, it's equal 0. So if you've already found the dot product, then it's easy to check that one. Which was the case for 11. So I did it both ways so that you could see. I found the slope of u and the slope of v. The slope of u is 2/5 and the slope of v is -5/2. Those are opposite reciprocals, which means this is perpendicular, and if they're perpendicular, it's orthogonal. And also the dot product is 0. So it would be good to sketch that, just because if you sketch it, it should look like it's got a perfect 90-degree angle, and then you can kind of check to make sure that you're right. And then the last ones were the angle between the 2 vectors. And the formula is here. So it's the cosine of that angle equals the dot product over the magnitude of each, or the product of the magnitude of each. So I'd get cosine -1 of -18, because that was my dot product, over the square root of 8 times the square root of 65. And you should have gotten 142.13. And drawn, it's definitely obtuse, so hopefully that helps you confirm your answer. 13 dot product ends up being -39, and then the magnitude of u was root 45, magnitude of v is root 73. So in the calculator, you have to do cosine -1 of -39 over the square root of 45 times 73. And you should get 132.88. So in order, this goes 6-3 and 6-4, and then the warm-up 6-5. Okay, so we kind of just did like a mini review of those 3 sections. And then 6-1 is your law of sines with your area if you're given side angle side. And then 6-2 is your law of cosines and the area of Heron's formula. You all are going to get 1 word problem from law of sines or law of cosines. And then obviously a complete triangle and both areas. So just make sure you review that stuff. Questions on anything today or that the review went over yesterday? Everybody feel confident? Yes. Okay.
How many questions?
14 questions. The law of sines, cosines, like that will have more weight, but the rest of them are going to have pretty much even weight. Okay. I'll give